Demand on the world's limited resources is increasing to an unsustainable level, and some forecasts predict we will run out of natural resources like cobalt and lithium within the next 100 years. These elements are vital components of lithium batteries, and as our demand for technology increases, it's vital these devices and their batteries are responsibly handled when it's time to recycle them. TES is privileged to be the partner of choice for some of the world's largest technology OEMs, hyperscale cloud companies, contract manufacturers, and electric vehicle manufacturers. We work with those partners to safely package, collect and transport their retired lithium batteries from their location to our recycling facilities in France and Singapore. The batteries arrive certified and sealed, ready for processing and repurposing by our team of over 200 engineers. From here, the receiving process takes place, and recovering the scarce materials inside retired batteries begins. Our team identifies and captures the relevant information on the job as the material is unpackaged. This is a part of our documented chain of custody process and creates the audit trail that helps our clients stay compliant with regulations and their own audit requirements. Once everything is recorded, the dismantling process begins. Where required, a subsequent discharging process will harvest the residual energy of the batteries. The recovered energy will be stored in the installed Second Life energy storage system and utilized for the following recycling process. Pallet IDs are checked again, and contents are photographed and logged before the sorting begins. Once segregated into battery types, the components go through the mechanical process, which is broken into two phases: size reduction and separation. First, the batteries go through a series of intense shredding and hammer milling, while thermal runaway is minimized. The process heat still allows the electrolytes to evaporate and be captured as VOC gases, all closely monitored to maintain safety levels. Next, we enter the separation phase of the process. Using a series of air, magnetic milling-based techniques, the core components of the batteries are separated into ferrous and non-ferrous metals. Papers and plastics are removed. Black mass powder is extracted during all these steps and preserved for use in the next stage. Black mass is the starting point for the four-stage chemical process, which starts with leaching to extract the fine precious metal elements. It also includes several cycles of reaction and filtration and produces graphite, cobalt hydroxide, and lithium carbonate materials, ready for use down the manufacturing stream. All processes are highly automated. They can be monitored and controlled from a central control center, as well as on-site by a sophisticated automation control system. The lab team perform quality control analysis on the recovered raw materials to meet the rigorous parameters of the supply chain for new batteries and to maintain the purest and highest commodity-grade recovery and purity rate in the industry. All the while, the facility makes sure there's zero discharge of wastewater, capturing sodium sulfate byproducts and using an on-site photovoltaic system and energy storage system to make the whole hydrometallurgical process as sustainable as possible. Because of all this, the raw materials needed for tomorrow's batteries can be reused in the forward manufacturing supply chain, driving down the dependence on sourcing scarce materials, offering an ethical, safe, cost-effective, and closed-loop solution for our planet and our customers.